everyone. So let's get started on worksheet 21. And for question 1, what we're going to use essentially are these two derivatives that we've seen recently in lecture. So this is something you could keep in your note card, and perhaps in the future you'd have it memorized. But this is something will come up often in the kind of questions you'll see on a test. Okay, so let's see how to apply this, for example, in 1a. So in 1a, we're trying to compute the derivative of tangent of arcsine of x. So I see a composition of functions. I'm going to do a chain rule. The derivative of tangent is secant square. That gives me my first term there. And then the derivative of arcsine of x is, as we have up here, it's 1 over 1 square root of 1 minus x squared. And that's this term right here. All right, so in this class, when we have the composition of a trig function and an inverse trig function, we're always going to have to simplify that. Okay, so we're not done at this point. We need to simplify that secant of arcsine. So let's draw a little triangle. So you see in this triangle, my opposite side is x and my adjacent side, my opposite side is x and my hypotenuse is 1. And that means that this angle here, theta, is arcsine of x, just by definition. And then I can use the Pythagorean theorem to figure out that the other side is the square root of 1 minus x squared. Let's not worry about the plus minus. Just write down the square root of 1 minus x squared. And then in that case, of course, secant theta must be 1 over 1. It's hypotenuse over adjacent, right? So it must be 1 over the square root 1 minus x squared. But remember that theta was arcsine x, so we have an expression now for secant of arcsine x. And we can just plug that in. So this was my expression for secant of arcsine x, and therefore I square it because we have a secant square here. And yeah, then this term just follows, we don't have to change it. It just repeats in the second line. And we can simplify that a little bit to get down to 1 over 1 minus x squared to the power 3/2. And we're done.